Okay, so we're talking about graphing trigonometric functions in today's video. And I've got a picture right here of a wheel that's unrolling. We used to have like a activity that we did in class that involved like taking a string and wrapping it around a can, and then we used to cut these paper strips out, and so we would measure these different things. But the process of unrolling the string was kind of an important concept of like we're looking at the circumference of a circle, but unrolled into a line. So that's kind of uh, the idea behind what we're about to do. So if you think of what would that look like if I just did unroll that circle into a line, well, here's a graph that I put together of it goes from negative 2 pi on to 2 pi. So if we're thinking of the unit circle has a circumference of 2 pi. At the origin here is where one circle unrolls perfectly, and going backwards, another circle would unroll. So you can think of this as two circles back to back. And I'm going to think about what happens when I graph the relationship between two different parts on the unit circle. Let's try this. Let's try right here. Okay, so I'm going to be going around and around the circle, and when I stop, I'm going to graph. So like here, I stopped at 3 pi over 2. 3 pi over 2 represents 3/4 of the way around the circle. So I would have to graph something. And what would I graph? Well, I have these two different values at 3 pi over 2. I have 0 and I have -1. So I don't have enough dimensions to graph both of them. So I'm just going to pick one of them. And let's say I'm going to pick the one that I'm going to pick is -1. So I need to scale. I want this axis to be, this is going to be 1. This is going to be 0.5. This is going to be -0.5. And this is going to be -1. Okay, so I know that this function that I'm graphing that represents or compares the length around the circle to the y value is going to go through that point. Let's go about it in a bit more of a methodical way. Okay, so the first point that I want on here is when I've traveled not at all around that circle. When I've traveled 0 radians, I should be at the point 0. Okay, so the point 0, 0 is there. Then the next point I want is when I've traveled pi over 6 radians. When I've traveled pi over 6 radians, the y value is 1/2. So the next value I'm going to have is 1/2 right there. When I keep going, I've traveled pi over 4 radians. The y value is √2/2. Well, that becomes clunky to work with, but something that you usually commit to memory at some point in pre-calculus, and it stays there throughout calculus, is that conversion of these fractions to decimals. And so I'll just give you both of the ones that you need right now. √2/2 is 0.7/7. √3/2 is 0.866 approximately. And there are lots of times when it's easier to use decimals than it is to use fractions. So at pi over 4 is where? Well, it's going to be right here along this line. So pi over 4 is going to be at 0.707. So I'm going to put it right there. When I keep going around the circle to pi over 3, now I've traveled pi over 3 radians around the circle. My y value is √3/2. So pi over 3 is 0.866, which is somewhere right there. Which I think this is. And then now I've gone a quarter turn. My next point is when I've gone a quarter turn, which is pi over 2 radians, and my y value is at its peak, which is 1. And notice the shape of this graph so far should correspond to what you know is happening. You may be confused at this point looking at all these different things that are so new to you. But if I were to just ask you, what happens as I move around the circle? Am I going up or am I going down? you could tell that I'm going down. Okay, or sorry, that I'm going up. And that's why my graph goes up. And then in this next quarter circle, you can tell that I'm going down. So you can expect my graph to go down. So then I get to the next one is 2 pi over 3. And my y value is root 3 over 2. So I'm 2 pi over 3. And now you can see I should be consistent with that line right there. I'm doing my best to. Then the next thing I get to is 3 pi over 4. At 3 pi over 4, that's going to be right here. I'm at 0.7. Then I'm going to get to 5 pi over 6. At 5 pi over 6, I'm at 0.5. And then I jump all the way to pi. And at pi, I'm back to 0. Okay? So I went up and I went down. And now I'm going down further. And you can kind of start to see the pattern. So now I'm at negative 1/2 and 7 pi over 6. Then I'm at 5 pi over 4, and I'm at negative 0.707. And then at 4 pi over 3, I'm at negative root 3 over 2. And then my next point is the one that I started with. At 3 pi over 2, I'm at negative 1. And you can look at this pattern and you can see that it's going to repeat. You may not even need to use the graph anymore. So I'm just going to kind of reflect it over this line. And it should be approximately correct. And the shape that I get is a wave. And you can imagine if I were to just keep going around the circle, I would repeat all these values. And so I just get this string of waves that has the property of being symmetric, where I would get an endless wave like this. And I didn't tell you what I was graphing. I only told you I was graphing the y value. And I don't know if maybe early on in the unit circle for you to have picked up on this, but what we want you to eventually know is that these coordinates on the unit circle represent cosine of theta, comma, sine of theta. So what I just graphed is y is equal to sine of theta, or sine of x. And the other thing I want to do is I want to graph the x values. And the next one I'm going to graph is going to be a graph of the cosine of x. And let's see. You know what I'm going to do is I'm going to try graphing it on the same graph, but I'll graph the cosine values in red. Okay, so now I'm going to start at the same spot. I've gone 0 radians around the circle, but my x value is no longer 0, it's 1. So the point that I start at is going to be 1. Now I go my first turn, and I go pi over 6 radians, and at pi over 6, I'm at root 3 over 2. Then I go another little bit, and I'm at pi over 4, and at pi over 4, I should be at root 7 over 7. So it looks like the curves intersect at that point, which makes sense because the x and the y values are the same. Then I'm going to go to pi over 3, and at pi over 3, my x value is now 1/2. Then I go to pi over 2, and at pi over 2, my x value is 0. Then I keep going, and I'm going to get to 2 pi over 3, and at 2 pi over 3, my x value is negative 1/2. Then my next plot that I'm going to point is at 3 pi over 4, and at 3 pi over 4, my x value is negative 0.707. And then at 5 pi over 6, I'm going to have negative 0.866. And then at pi, my x value is going to be negative 1. So if you were to ask, if you looked at what's happening to the x value as you go around counterclockwise around the circle, it's going from right to left. The reason, and since our number line gets more positive and bigger as we go from left to right, we see the function is decreasing over that whole interval. And maybe you're able to anticipate what's going to happen next. So now we're going back from the left to the right. So the function starts to rise. It's still negative, but it starts to rise a little bit. And it's going to be at 0.866, which is down here. Now I see this should be down here. And then 0.707, and then 1/2, and then 0. And then you can just check and make sure that I've done these correctly. And you can also see that what's happening now, we're still going left to right. We're graphing the x-axis, which is the cosine of the angle. And we expect that it's just going to keep going up. So at 5 pi over 3, we have 1/2. At 7 pi over 4, sorry, we're doing the x values, we have 0.707. At 11 pi over 6, we have 0.866. And then at 2 pi, we have 1. And we're back to where we started. And so if you want to picture what this is going to look like, well, let's see, it should look something like this. And you can see that both the red is the cosine of x, and the black is the sine of x. They have some things in common, but they're also a little bit different. One of the things that's different about them is the starting point. And this is a big thing because we're going to be looking at a lot of these graphs here. What's important to remember is that sine starts, and when I say starts, I mean where it is at 0. When x is equal to 0, it is at the origin. Okay? If I look at cosine, cosine is on the top. If I show you these things in Desmos, if I say f of x is equal to sine of x, these are things that you want to be aware of, is that the sine of x function, it goes through the origin. Okay? When I say where does it start, I mean where at 0, it's starting right here and it's going up. When I look at the cosine function, where does it start? It starts at the top. Okay? So it starts at the top and then it starts going down. It starts at the point 0, 1, whereas sine starts at the point 0, 0. That's enough for today. It's a lot to wrap your head around, but keep in mind that these two functions are very similar. In fact, if I wanted to make a horizontal translation of one, I could move it to some point where they completely overlap. But without that translation, they're different in where they start.